the wax. Otherwise, it becomes very warm. Okay,
So how many
that's
years
it.
you used to make the...
Can I see?
So many years you used to make?
You can estimate the age. But it is. Let me see. Dry a bit. It will start to wet. Now, the other thing I can show you is this. You see these two parts? The brown one and the lighter one. This part is used for conducting water. This is not functional anymore. Okay? So, as time goes on, as time passes, the old vessels become inactive. So this is why the tree needs to produce new rings each year. Okay, because the old ones, so this would be functional, let's say 30%, 40%, 50, 60, 100%. So each time the new vessels produced would be 100% functional, and the old ones.
So that's why you can have some holes sometimes in trees without having problems.
Exactly. So this becomes
In all the trees.
in all the trees. This tree that has honeyed or something like this. There's no problem because they are using the outer rings for conducting water. So
This is also why you can kill them by making
you kill them if you kill the cambium.
Just making something around it.
Yeah, you kill the cambium. Actually, what you kill is the cambium and the phloem. You stop phloem. The xylem will still be active, but the phloem will die. So, so in this case, I'm not sure. Let's say it's
Estimation.
yeah. Now that it's drying, the
Not
rings
a
are
week.
becoming more visible. Maybe if we wait a couple of minutes, I will just give you
Let's say
a rough estimation.
30, 40, 70, 100. Here's the
3 to 1 to
300, they say. 300?
So I would say that this is below 60 years old. Yeah, definitely below 60.
There is no influence of the branch, the upper branches. If you have upper branches, then you have more water at least.
Well, it would be a problem if we would sample here, for example. Here, this,
That's because of the shape.
yeah, because of the shape. But here, no, we won't have a problem. Usually, we
But does
select.
it have more rings underneath the
Yeah,
tree?
the question that I
Rings
posed earlier, yes. So here we would have all the rings that are available, okay? Because we would have the tree when it was this small, and then it started growing, and producing new xylem. Here we will have a number of rings missing, okay? This depends on how fast the tree is going. If the tree is growing slowly, then we would miss a lot of rings. If it's growing fast, we would miss 5, let's say 10 rings maybe. But it depends on the growth rates. Okay? If it's growing slowly, we miss many rings. So usually, in order to assess this, we will need to pour here as well. And count here and count here to find the difference.
But it's not related to the rings. The number of vessels going up.
The number
They
of
have the
vessels.
same number here and here. Or was it just 3 goes like this? So just it's very small, and then
No, the vessels would be similar.
they are defined.
Yeah, they are defined by other factors. No, the vessels would be the same thing. What would define the vessels is the season, because cambium becomes, it depends. It has different environmental factors that drive it. So during as I told you before, during the beginning of the growing season, the vessels would be white, and then cambium would produce smaller vessels, more lignin in order to support the weight. Okay. So the late wood has more lignin, early wood has less. Okay, any other questions?
But you know the second one where
I would go from this side.
this is
I would go this side.
okay.
and then we can see there. Because the tree is going that way,
Yeah,
so it's 90 degrees here, 90 degrees here, whereas here it's different. It's 100 and or the opposite.
Some
Okay?
people analyze elements in
Yes,
the rings.
yes,
I
this
was
is
going to ask about nitrogen, but the other
Okay.
but also
Now, another interesting thing that we can do with tree rings is use it as an archive for different things. Because we can date, we can identify the situation or the conditions that the tree experienced the years before. If we have very old trees, some trees can grow more than 1,000 years old, okay? We have a valuable archive, and usually this archive is used in climatology. We use it to reconstruct past climate. Now this is one use of tree rings, but you can also assess the ecological conditions that the tree experienced. And you can also, if you are interested in forest dynamics, you can see if climate is more or less stable, if in cases like this, you can have an assessment of how competition changes inside the tree, inside the forest. If the tree, the canopy closes and competition increases, then growth would be reduced. In some cases you could see that, yes. In some cases you could see that.
How?
But you need to sample.
Can you disentangle the climate from the competition?
Oh yeah, you need to have information of climate. So if climate is known, you have one parameter known, then you can understand the unknown. If you have too many unknowns, then it's a problem.
Having single trees quite more isolated at the moment would be better.
Yes. For understanding effects of climate or other factors, it would be good not to have too much competition, because that would affect growth, variation. Fire would also be a factor to consider, or other management that would have affected the growth of the tree during the previous decades.
In previous assessments that you have or in references, how much competition can affect the growth?
It can affect growth drastically, because, for example, if we have, maybe we can try this and try to find dense stands like that over there, with similar age trees, and open trees that are less dense here. If we have trees 5 meters in radius from this tree, and you would cut them down, in the next 2 or 3 years you would see big rings on this trunk. Okay, so you'd see an effect that would be, because nutrients become available to this tree, water becomes available, everything is now its own. It does not share it. So this is an important factor. So competition is another factor you need to consider.
Not light.
Light is another factor, but
Tropical area.
in Mediterranean conditions, it's not the basic thing to consider. In northern latitudes, yes, because there light could be a very important factor when you have trees growing next to each other. In this open stand, I would not see it as a
definitely
base.
here now, but in many
Yeah.
tropical areas.
Light can also be a factor. Usually, we would, and this is what I'll show you later, we would try to find the trees that are the most dominant, that are not shaded. Okay, because then you would have these factors not so effective. Okay, for example, if we see around us, can you find me a tree that is shaded? Maybe that has an effect.
Well,
Maybe
this
here.
one is shaded, but it's on the southern part a little bit by this tree.
Yes, this is a tree that is affected. Usually, you would see this effect. You would see the tree leaning away from the tree that suppresses it. So you see it's going that way because it wants light, does not want the canopies to merge, so it's going that way. So this tree is a bit more suppressed. Maybe we have some other trees we can show you. I cannot see many around us. Or that over there, you can see. Those trees that are bending, it's either because of wind or it's because of light stress, to avoid stress during the first years of growth, and then it continues that way. So it's good to have trees that, sample trees that are dominant, so we could, in this case, we would sample this tree, we would not sample this tree, in order to have these factors under control. Yes?
So you're saying that you would choose dominant ones, like for the Astoria or whatever tree,
The dominant
and
trees.
you
Yes.
wouldn't care about how,
The peripheral, the circumference.
or you would prefer to have them more or less the same, so you can actually.
Well, this is a topic that we is very interesting in dendrochronology because we have a factor of age, which is very important. Now, what happens once trees age? Now here we have a particular, here we have a width, but also a volume of wood that is produced. Okay, so we have the vessels that are produced each year, and they have a particular volume. Now, when we make a sample like this, and we measure width, we do not measure volume, we measure width. Okay, and imagine you have this tree during its first years of age, and you have this tree 60 years later. And you have the same volume of biomass around this tree and the same volume of biomass around this tree. What would happen to the width? The width here would be very small because this volume would spread around a bigger surface. Well, in this case, this volume would spread around a small surface and you have the big rings. So this is another phenomenon we call age trend. In each tree we have this. During the first years of growth, you have higher, wider rings. Not because of climate, not because of other factors, just because you have anatomical characteristics as the one I described.
So wood density is very constant.
Density, another factor. Just a minute. Let's go to age first. So, in order to be sure that we are studying trees and we are measuring width, well, we can convert width to basal area increment, which is something different, and its surface, and it helps correct this problem. But another correction is just sample trees that are the same age and compare growth between trees of the same age. In this case, we are certain that we do not have the factor of different ages. Okay? So the best thing is to find trees of the same age and compare the difference.
It's the same growth rate.
Yes. Well, yeah.
Similar growth.
If we have
A
the
range
same
of
condition,
birth
because
diameter.
I will tell you later that we will play with this in order to have a rapid assessment of productivity. We will play with this factor. We will try to have trees that are of the same circumference, they have the same size, and we will try to count the number of rings within this particular circumference. Many rings means we have slow growth rates. If we have little rings, we will have wide growth rates. Okay? So this is a fast way of understanding if trees are growing fast or slow. We will try this later. The problem that I see here is that we will not be able to assess this on the field. We will need to sand them because the rings are not visible. Instead, we could use pines. I don't know if it's permitted. If we use pines, we would have the rings directly visible, and we would have an assessment of productivity. But it's up to you.
I have a question. Yesterday we had here.
We have the density issue then.
If you want to answer the density,
No, that's okay.
because yesterday we had here a professor from agronomy, and she's studying the cork, the quality of
The cork,
the cork.
yes.
Yes, and then she's following 50 trees. We were in the same place.
5-0?
50 trees since 91. In terms of growth, so she has
Diameter.
dendro,
Bands,
dendro
yes.
bands.
Dendrometers.
Dendrometers.
To assess the growth
Yes, to
each
assess
year.
the growth.
Okay.
And she found that from the 50 trees since 91, 5 of them died and were the ones that were growing at faster rate.
The ones that were growing faster died.
Yes, and the bigger and the faster.
Well, this is
and
interesting.
then she couldn't explain this, but you have it from a different area. I will just slept with this information in my head.
No, we are going
And
even
we were
deeper.
just discussing
Yeah, yeah.
this. Can you just help?
Yeah, I can
questions?
provide some answers based on some of my research findings, and because I study mostly tree mortality, so this is close to that's my field of expertise. So if you have a tree growing fast, what do you have in the canopy? More foliage.
Yes, more leaves. Yes.
Okay. So when it gets dry, what happens to this tree?
They have more evapotranspiration, so they need
Exactly.
more water.
And if this tree is, for example, in a situation where there's a lot of surface water, or a lot of water wherever it has its roots, surface or deeper ground, it has water, and you cut off these supplies, then you have a tree that has a big evapotranspiration rate, but not enough supply to support this evapotranspiration. So this tree can be more vulnerable.
Only on dry years. So they don't
On
die
dry
on
years.
dry years.
Dry years, yes.
I'm not yeah.
So
They sacrifice leaves.
they can sacrifice leaves. This is the first thing they would do. They would sacrifice leaves because of this. But it depends on the drought. And it depends on competition. Things like that. So if they have competitors that are available, they can take the water away from them during that period, and shedding the leaves is not sufficient.
So you recommend hydraulic failure?
Yes, I'm in favor of hydraulic failure.
So in some way, there's an here. You want trees to grow faster because you won't have corn and wood.
But
In the dry environment, they will
Had
be
more vulnerability.
and more vulnerable.
Had more vulnerability.
We are selecting the wrong trees on that basis, especially if the climate change goes to more dry.
yeah, this is an interesting point. This is an interesting point, because if you want to have the more resilient trees,
We have the trade-off is the lower growth rate. But should we water those trees?
well, if you water,
Because
you
in
would
some
save
way,
them.
what this means is if they have the capacity to grow at fast rate,
Yeah, yeah.
you only need to
If you would irrigate, you would.
evaluate.
Yeah.
So if this is only happening, you need to evaluate when are dry years, and then you can keep the tree
Yeah.
growing.
Then you
Because
would.
you don't have all the trees dying on that year. So that's
This,
I'm not convinced on that too. But
in this
anyway.
case, if you would irrigate, I would say not too much, just during the dry season,
just to keep
the cambium active, you would help them survive. But the amount of water that you need and so on needs to be tested. Now we would need to find an agronomist that is his or her field of expertise, and people that irrigate trees and work with irrigating trees will tell us about.
Can we generalize this? So when I have the mortality of trees, is they are always the faster growing trees? Can I
Not always,
generalize
no,
this?
no, because we also have the mortality in the most stressed trees. Because the trees that are also very stressed are already in a situation where the resources they have are very little, and the effect that they have is from, for example, from solar radiation or from other factors that they had very, for example, shallow soil, which is also something interesting. So right now, this field of research is under intense investigation. In order to understand, we have one paper published recently on global change biology on this. It's a global synthesis of vulnerability to mortality. And lots of work needs to be needed in order to identify the question that is answered by the word "it depends." Okay? It depends on the situation, the system that you're working with each time. So in this situation, and in this system, we need to have an assessment, and then we will say more or less what is going on. Yeah, I would say.
Portugal, they have been doing assessments about maple sugar because it has had so economical return. And the main conclusion is it's multifactorial, so it depends when you are. So I think in some places it's because they destroy the superficial roots and they become susceptible. In some other places it's because then there is a disease, and others it's because they are at the limit of distribution. In others it's because they are subject to severe pollution in some industries.
Yeah.
So there are so many,
factors.
multifactorials, and they don't identify a general factor. Depending on the location, I don't know really because I've never been. It's just what they say. Anyway, so
yeah, it depends. So the question, well, the problem, Mediterranean climate, as we said, the main driver is water availability. So if that becomes less, and that will increase vulnerability of the tree to different other factors. Insects, fungus attacks, whatever. So tree has defenses, but the defenses depend on water, and it's and the vigor that the tree has. When this water is less, then things become problematic. And the weaker trees are the ones that would be attacked more easily, and they would be the first to die. But vulnerability inside the ecosystem is something we need to investigate. Talking with Adriana. There are possibilities to use some indicator, for example, solar irradiance, as some indicator of something like this, and see where do trees have higher drought stress because of influence of radiation and things like that. So in microclimate situation, there are things to evaluate, but in general, there is a global trend of increasing mortality because of increases in drought in different parts of the world. This we have documented, and it's usually at the xerothermic edges of tree distribution ranges. Okay, this is another important factor. You have trees that have a range in terms of where they can grow. You have the cold limits of the distribution and the xerothermic limits of the distribution. In the first situation, temperature is a limiting factor. In the other situation, it's water availability. So at these margins, at the drought margin, we have the highest mortality rate because trees have already given up all their potential to adapt to a particular environment, and they are at the margin. So in this situation, we have mortality, and it's high. In other situations, you need to assess microclimate. Okay. Okay.
thank you.
Other questions? Yes.
How does fire history show up?
Okay, interesting. Fire history. Fire causes scars. You would, for example, here we would have a ground fire, not a canopy fire, that would permit the tree to survive. And cork oak usually has this defense against fire. This is a fire defense. So if you have a ground fire and it burns and damages the cambium a bit, then you would have a scar. And this scar can be dated. And if you have another fire event that also does not kill the tree, it would usually burn on the same situation because the tree would be more vulnerable. It would have less defense. So it would burn more. So you have another scar. And gradually you have trees that produce an archive of these scars. You can date these scars, and you can understand the fire history of the area, not using one tree, but usually tens or hundreds of trees that have these scars. You can find the synchronicity between the trees and find out if they have the same scar during the same year. It means that the fire burnt the area, and you can make assessments of where the fire burnt, and depending on that you can assess the severity. There are papers published that I can show you literature on that. Usually trees that have these scars are trees with thick barks. I don't know about Quercus suber, right? But Pinus nigra, you know Pinus nigra? It has also a thick bark, and it is a very good tree for fire history construction. You need to have trees that have big bark that survive the fire and can be scarred. Pinus, for example, halepensis or Pinus pinaster, I do not know. Maybe they will burn completely and they do not leave a scar. The other thing you could check out is if you have the growth rates, you would see in the curves that you produce a rapid decline and then a rapid recovery, even if you don't have a scar. And that would be an indication that you have fire. But you need to see that in many trees, not just one. And you would have the same effect if you have a damage in the foliage, for example. Some insect attack or something, you would see a decline and then a rapid recovery. But with fire it's more rapid because you have nutrients released, you have competition that is removed, so the recovery is fast. Other questions?
Do you think you get that effect when they remove the cork as well from the tree, that it could affect it for a number of years?
Well, of course, now it's vulnerable to fire, I would say, yes.
Well, just not so much the fire, but just in productivity as a result from taking the cork.
If productivity changes from taking a core or from the bark?
From taking away the cork.
The cork.
Yeah.
If productivity changes. I do not know actually. Someone can study this.
I think there are some studies with that, yes.
Yesterday Maria also was showing the graphs of the growth and there was really no effect.
No effect.
At least they could not detect
That's what
an extra effect. But it's still
Yeah.
possible, so
Yeah.
when you sample, take note
Yeah.
of the date when it was last harvested.
I'm not sure if there would be an effect. No, I don't know the answer to this. I have not studied and I don't know the literature. But usually this is protective armor against fire, so I don't think it would affect growth. Okay. Other questions? Okay, we covered lots of
We are
things.
done.